Hello everyone and welcome. Today we are going to understand one of the most powerful and mysterious inventions of our time, the quantum computer. By the end of this video, you will understand what it is, how it works, and why the whole world, from governments to the biggest technology companies, is racing to build one. So let's begin. First, let us understand a normal computer, the one in your phone or laptop. Every classical computer speaks a very simple language made of two symbols, 0 and 1. We call each of these a bit. A bit is like a light switch. It is either off, which is 0, or on, which is 1. Everything you have ever seen on a screen, every photo, every video, every game, is just billions of these switches turning on and off very fast. Classical computers are incredibly good at this, but they do one calculation at a time, in sequence, no matter how quick they seem. Now here is where the quantum computer changes everything. Instead of a bit, a quantum computer uses a qubit, short for quantum bit. And a qubit does something that sounds like magic but is real physics. A qubit can be 0 or 1 or, and this is the key, both at the same time. This special state is called superposition. Imagine a spinning coin in the air. While it spins, it is not simply heads or tails. It is a blend of both possibilities at once. Only when it lands does it become one answer. A qubit works like that spinning coin. Why does this matter? Because if you have one qubit in superposition, it holds two possibilities. If you have two qubits, they hold 4 possibilities together. 3 qubits hold 8. Every qubit you add doubles the number of combinations the machine can explore at the same time. Just 300 qubits could represent more numbers than there are atoms in the known universe. A classical computer would have to check those possibilities one by one. A quantum computer explores the whole landscape together. That is the source of its incredible power. There is a second quantum trick called entanglement. When two qubits become entangled, they are deeply linked. Whatever happens to one instantly affects the other, even if they are far apart. Albert Einstein famously called this spooky action at a distance. Entanglement lets qubits work as a connected team, sharing information in ways ordinary bits never can. Together, superposition and entanglement give the quantum computer its almost unbelievable abilities. But quantum computers are also extremely delicate. Qubits are so sensitive that a tiny vibration, a little heat, or a stray particle of light can destroy their quantum state. This problem is called decoherence. To protect the qubits, scientists cool these machines to nearly -273 degrees Celsius, colder than deep outer space. That golden chandelier-like machine you may have seen in photos is actually a giant refrigerator keeping the qubits calm and stable. So what will we actually do with this power? Quantum computers are not meant to replace your laptop for email or videos. They are built to solve specific problems that are simply too big for any normal computer. For example, designing new medicines by simulating molecules exactly, creating better batteries and cleaner energy, improving weather and climate prediction, making artificial intelligence smarter, solving giant logistics puzzles, like the fastest routes for millions of deliveries. These are problems where the number of possibilities explodes so fast that classical machines would need thousands of years, but a quantum computer could crack them in minutes. Of course, there is a serious warning side too, which we will explore deeply in later videos. The same power that designs medicines can also break the secret codes that protect our banks, our messages, and the entire internet. That is why quantum computing is not just a science story. It is a security story for every person on Earth. Where are we today? We are in the early days, much like classical computers were in the 1950s. Companies like IBM, Google, Microsoft, and many startups and nations are building bigger and more stable machines every year. We are not yet at the point of everyday quantum power, but progress is accelerating fast. So to summarize, a classical computer uses bits that are 0 or 1. A quantum computer uses qubits that can be both at once through superposition, linked together through entanglement, giving it enormous parallel power for very special problems. It is delicate, it is revolutionary, and it will reshape science, industry, and security. If you found this helpful, please subscribe, because in the next videos we will explore quantum cryptography, the quantum threat to encryption, and how entire industries will transform. Thank you for watching, and I will see you in the next lesson.